Today's topic is all about GMO food. So GMO food, miracles or monsters? Few of you maybe don't know what is GMO food. So we're gonna learn about each and everything about the GMO food. What are the benefits and what are the issues with the GMO food? Whether they are beneficial for us or whether they are harmful for human life. So all the things we're gonna learn about the GMO food. Okay. Going forward, I would like to request you to please do not forget to subscribe my channel, like my videos, and share and comment. Okay. If you have any query, any suggestion, please write in the comment box. So I'll go through that and I'll answer them also. And if you like some other training videos that you want me to make, so I will make them also. Okay. So let's get started. So, first of all, I would like to introduce myself. As I said, my name is Pom Narayan. I'm working as a QHS manager and I have a total experience more than 10 years and last 8 years I'm working in UAE. Okay. I have worked with the different industries like catering, facility management, event management, hospital, education, oil and gas, and so on, and other different sectors as well. I have the master degree in occupational health and safety management system, and I have a NEBOSH international diploma in health and safety management system. I have a food safety diploma, and I have done advanced food safety level 4 certified by UK HABC certificate and HACCP level 4 certified from the UK as well. And I have the lead auditor certification like ISO 45000, 9001, 14001, 22000, and the HACCP certification as well. I am a certified Lean Six Sigma Green Belt and I am certified Fire Warden and the First Aider. So this is all about little intro about myself. So that's all. And I am a certified trainer from the Dubai municipality as well for the food safety and the health and safety. Okay, so let's start. So first of all, we going to learn about the GMO. What is GMO and how it's going to impact our life. Okay, so GMO, it's we can call this one genetically modified organism. Okay, most of the people they call this GMO, it's a GE, genetically engineering. Okay, it involves the insertion of DNA from the organisms into another or modification of an organism's DNA in order to achieve a desired trait. Okay, so plant breeding today, GMOs and other techniques which are being used in the farming industries and the farmers they are using day by day. These are the different techniques people they are using around the world to get the better crop and better production from the farmer and the food also. Genetically modified organisms, a GMO crop is developed using technique that enable us to take a beneficial trait like insect resistance or drought tolerance from one organism and transfer into a crop plant. Okay, so let's say that how scientists they are making a genetically modified organism. So here are the 10 GMO crops commercially available in the US today. Okay, and these are the crops are available around the world also, but this is the data for the only for the US. Okay, first one is corn. After that, soybeans, cottons, canola, alfalfa, sugar beets, papaya, squash, apple, and potato. After that, traditional cross breeding, how it's happening. Let's say combining the desirable traits of two plants to create a new and improved variety. Many apple varieties, such as the Honeycrisp, were developed in this way. Let's say I have two apples and both the apples have the different varieties. Maybe one apple is more sweet and the another apple is red. So what I want is I want one apple which should have the both quality. It should be sweet also and it should be red also. So what I will do, I will take the both from the both apples, okay, sweetness and the color from the each apple, okay. Then after then what I will do, I will do the cross breeding. In this cross breeding, when I will make this process, after this process, the new apple will which I will get, it will contain the both quality. It will be sweet also and it will be red also. How GMO is working. After then we have the mutagenesis, using and other mutations and other mutagens, physical or chemical, to induce random mutagens in plant, activating new desirable varieties. This process help deepen the color of the ruby red and star ruby grapefruits. So what in the mutagenesis process, what they are doing, they are taking and the other mutagens, okay, and after that getting the new product that will be new, and it will be more reddish also, more red color it will give you to the fruit. After then another one is a gene editing. So in the gene editing, CRISPR-Cas9 or Tollens target specify locations within the plant's genomes DNA and allows for species edits and deletions. Low gluten wheat and other desirable traits that might be hard to achieve with conventional breeding have been created using this tool. So let's say that while if there is any gene in this product, so this gene will be edited. So after the editing of the gene, the new product which you will give, you will get the exactly desirable product which you want. Okay, so this is the whole process of GMO and the techniques, and these are the techniques are available which are being used in the food industry: traditional crossbreeding, mutagenesis, and gene editing. So how this process is work? So genetically modified organisms, what will happen? Let's say taking the bacterium from DNA, okay, and cell from another organisms. After that plasmid it will take from here. After then gene of interest it will take both of these will be combined. After that recombinant DNA. When you will get the new product, it will contain the both benefits, one from this one and one from this one. So this is your new product: bacterium with recombinant plasmid, cell division and reproductions. After then it will divide the cell, and after then reproduction will start. These are the some examples of genetically modified organisms, and example why we need to grow the GMO crops, okay. So here are some example why we need to grow the GMO crops. GMO crops were created for the insect resistance. Uh, about a month or 2 months ago, you have seen the news that so many insects in Afghanistan and India, they destroy the whole crop in Punjab and the North UP side. Okay, so those insects, they attack the whole crop and they destroy that one. To avoid the insect on the crops, people, scientists, they have grow the GMO crops. So the new crops which will be created, that will be the insect resistance, to provide farmers with season long protection against pest, reduce the need for pesticides applications and lower input cost. So while farmers, they will grow the GMO crops, so they don't have to worry for the pest, they don't have to worry for the insect, and they don't have to put too much chemical on the crops, because the new crops, it will be insect resistance and there won't be any problem about the insect. After that, drought tolerance, to increase water retention and allow crops to better endure drought conditions without the need for additional irrigations. To avoid the water consumption or reduce the water consumption by the crops, that is also one of the reason that GMO crops were grown. After that, herbicide tolerance, to allow farmers to fight weeds by applying targeted herbicides only when needed and enable them to use conservation tillage production methods that preserve topsoil, prevent erosion, and reduce carbon emissions. So these are the reasons also herbicide tolerance, GMO foods grow. And disease resistance, to enable plants to resist certain disease such as the papaya ring spot virus. For example, the GM rainbow papaya you can see here allowed Hawaii papaya farmers to recover when the devastating disease crippled their industry. Okay, so these are the reasons why farmers they are growing the GMO crops, and scientists they are helping on this. After that, enhance nutritional content, to create food such as soybeans with an enhanced oil profile to make them longer lasting and trans fat free. So some of the foods they have been like genetically modified to get some additional benefits from them. Okay, like soybean, it's genetically modified with an enhanced oil profile to make them longer lasting and trans fat free. This is one of the reason. After that, reduce food waste, to eliminate superficial browning and bruising when products are cut or handled in potatoes, for example, to reduce the amount of produce thrown away by producers, processors, retailers, and consumers. To avoid the food waste, to reduce the food waste also, GMO foods has been grown also. Improved manufacturing process, to enable more efficient biofuel production in certain corn varieties, for example, by improving the process by which cellulose or starch is broken down and converted to fuel. So it's been used in the fuel also, making the biofuel as well. This helps to reduce the environmental impact by decreasing the amount of water, electricity, gas needed to produce biofuel. So by this process also we can produce the biofuel as well. So what are GMO crops? The most sorry, the most common GMO crops include soybean, okay, maize, cotton, canola, and alfalfa. The following GMO crops were also planted in different countries in 2018: papaya, eggplant, potato, apple, safflower, pineapple, and sugarcane. You can visit the ISAA website for more information on GMO crops and around the world. Okay, and these are the 10 GMO crops which is being growing around the world. GMO is been using in the medicines as well, like insulin, clotting factors, atrin, banana vaccines, cancer fighting eggs. So GMOs are also being used in the medicine industries as well. So these are the example of some genetically modified foods. So it's called BT crops. Okay, how it's started. So there is a problem that on the corn, this is the insect which will destroy the corn. To avoid this insect, it will not destroy our food. So what scientists they have done, they have BT gene transferred from the bacillus into corn. So this gene from the BT crops they have transferred to the corn. After that, what will happen, European corn borer feeds on the corn plant and ingest the protein encoded by the BT gene. So it will get the protein, this insect, whenever it will come on the corn, it will get the protein. And after that, what will happen, the BT protein penetrates and collapses the cells lining the gut, and the insect dies. So through this protein, when it will reach to the insect guts, it will die. So this is the whole process of BT crops. Let's call the BT crops, and through this process we can avoid the food waste. Our these insects they cannot waste our or destroy our food, so we can avoid destroy of the food. After that, GMO in manufacturing. So what scientists they have done here, they have produced silk in milk to make biosteel. Biosteel, what is a biosteel? Biosteel was a trademark name of high strength fiber based material made for the recombinant spider silk, like protein extracted from the milk of transgenic goats Okay, so they are extracting the silk like protein from the milk. From the goat milk, they are extracting the silk. After that got made by the Montreal based company Nexia Biotechnologies and later by Randy Lewis lab of the University of Wyoming and Utah State University. So what they are doing, they are taking the milk from the goat and they are taking the silk from the spider, and after then they are making the biosteel. GMO in pesticides. So cabbage, cauliflower, most of the caterpillars, they're destroying the food. And these caterpillars, if you will avoid during the food production, they can end up in our food and cause the food poison also. To avoid the caterpillar, scientists what they have done, they took the poison from the scorpion. Okay, this scorpion poison is used to make the pesticides. So whenever we will spray this pesticides on these vegetables, so what will happen, caterpillar they will die. So this poison is for the caterpillar, so it will kill the and it will not make any harm to the human. So the pesticides also caterpillar GMO it's been used. If you will see these are the data around the world, and these are the countries which is producing the GMO food. Global area of biotech crops in 2018 and 19 by country million hectares. So this is the data by 2018 and 2019, and these are the countries which is producing the GMO food. As we can say, number one is the USA. It's producing this much of food in 2018 and it's decreased into 2019. Brazil is there, Argentina, Canada, India, Paraguay, China, South Africa, Pakistan, Bolivia, Uruguay, Philippines, Australia, Myanmar. Okay, so 29 countries are there who's producing the GMO food around the world. So this is the whole process of the GMO potato from farm to plate. So the whole process is being explained here, and this is from the USDA, United States of Department. Okay, GMO go through rigorous review. So before starting to produce any GMO food, before farmer they start to produce any GMO food, this is the whole process scientists they are following. So what they will do, GMOs go through rigorous review. It will go for the review. On average, GMOs take 13 years and $113 million of research and development before coming to market. So suddenly it will not come to the market. It will go for the certain reviews. Scientists they will review it. Food department and the another government department they will review it. Once they will confirm it, only then it will come to the market and it will go to the farmers and they will start to produce the food. Approval is conducted by USDA, EPA and FDA, Food Department Authority. After that, GMOs allows farmers to grow more with less resources. So once it is approved, it will go to the farmers and farmers will start to grow the GMO food with less resources. In a single year, GMOs allowed farmers to use 59.7 million fewer acres of land to grow the same amount of food. So it will reduce the land which we require to grow the food. After that, the third step, GMO potatoes reduce pesticides with late blight disease protection that enables farmers reduce fungicides by 50%. So the food which is being produced by the farmers, it will also reduce the pesticides as well, because the new product which is already genetically modified, it has the resistance to fight with the insects. After that, GM potatoes reduce food waste via the non-browning, non-bruising trait. Potatoes bruised during storage and transport contributes to 400 million lbs of food waste each year. So it will reduce the food waste as well. Food waste as well. After that, enhanced food safety. GM potatoes have reduced acrylamide, a potential carcinogen formed during frying. So it will reduce the acrylamide also, okay, and it will enhance the food safety as well. The sixth process is the GM potatoes are safe to eat and sustainable to produce. So this is the whole process of GMO potato from farm to plate, growing from the farm and it's coming to our plate. This you may have seen the pineapple yellow color, but now if you are seeing any pineapple which is pink color, so do not get surprised because it is already in the market. In 2020, USA Del Monte, they produced this pineapple and they have the copyright of this pineapple as well. Scientists turned pineapple pink by changing a small enzyme that controls the color of the fruit's flesh. So there is an enzyme in this food which is control the color of the food. So scientists, what they did, they changed the enzyme and they changed the color of the food also. An enzyme is substance that creates a specific biochemical reaction. In this instance, typical yellow pineapples have high levels of enzymes that change the pink pigment called lycopene into a yellow pigment called beta carotene. To make the pineapple pink, scientists reduced that particular enzyme so the pineapple stays pink instead of turning yellow. So it's not turning yellow, it will stay pink. And it was produced by Del Monte and they have the copyright. It was first launched in USA in 2020. So the question everyone has in the mind, are GMOs safe? I can say GMOs are safe also one side and other side they are not safe also. First of all, let's see why they are safe and after then we'll look for the why they are not safe. So the health and safety of GMOs have been validated by many independent scientists. So what they have done, scientists they go through the GMO food product, they done the researches and they analyze the data and after then they decided that yes, GMO foods are safe for consumption. Group ranging from the World Health Organization, the Royal Scientists of Medicines, the European Food Safety Authorities, and the International Seed Federation, along with various governing bodies on every continent around the world, have all affirmed the safety of GMO crops. So all these countries, scientists, uh, they involved in the what you call this review process and they check the data, they analyze the data and after then they said yes, it's safe for consumption. Since 1992, more than 40 government agencies have been approved for GMO food, feed and cultivation. In many countries, multiple agencies are involved in the regulations of GMOs. GMO research, review and regulation. How does a GMO get to market? On average, GMOs take 13 years, as I said earlier, and it will take around $130 million before research and development coming to market. The regulatory process alone can take 5 to 7 years. Regulatory science, 75 plus different bodies are conducted to demonstrate each new GMOs. They will safe to grow and they will check whether it is safe to grow or not, safe for the environmental beneficial insects or not, whether it is safe for consumption or not. So all these things they will check it. Once they say it is okay, then it will come to the market. So this is the whole process of GMO coming for the research, review and regulations and it's coming to the market. GMOs and animal feed. Same nutrition and safety, food, health and nutrition, safe GMO crops. So GMO also is being used in the animal feeding also. More sustainable food, less land needed, fewer greenhouse gases, reduced environmental impact due to GMO crops. So this is the one of the examples, some genetically modified foods. It's golden rice. Okay, it is genetically modified and rice color is changed from white to golden color. Some genetically modified foods, how they compare, you can see it is the bigger one. It is the genetically modified salmon. Length is 24 inches and the weight is 6.6 lbs. But the farm salmon, which is real, which is not genetically modified, length is only 13 inch and the weight is 2.8 lbs. Both fish are 18 months. They have the same age. Okay, but both they have the huge differences because one is genetically modified, other is normal fish. So that's why they have the huge difference. So GMO food and health. As I said, there are some issues with the GMO food as well, and they have some health issues also, and they can make us like sick also. They can give us illness also, and there are some other issues with the GMO food as well. So one of the reason is toxicity. Genetically engineered foods are inherently unstable. Each insertion of a novel gene and the accompanying cassette of promoters, antibiotics, marker systems, and vectors is random. Genetically engineered food producers simply do not know where their genetic cassette is being inserted in the food, or nor do they know enough about the genetic chemical makeup of foods to stabilize a safe place of such insertion. So genetically modified, whenever the farmer they using these genetically modified organisms and the DNA, they don't know about it. So if they don't know about it, that how much amount they have to use it, where they have to use it, so it will cause the toxicity in the food. Okay, each genetic insertion creates the added possibility that formerly non-toxic elements in the food could become toxic. So if there is any non-toxic elements in the food, that can turn up in the toxic elements of the food due to wrong knowledge, insufficient knowledge, and people they don't know how to use it. That is one of the risks as well. After that, allergic reaction. The genetic engineering of food creates two separate and serious health risks involving allergenicity. As we know that while we are producing GMO food, we are taking the two different DNA, two different food characters we are taking. And it could be possible that one food is allergenic and the other food is non-allergenic. So when you will combine both together, the new product which will come, it will definitely will be the allergenic and it will give you the allergic reaction. The first is that genetic engineering can transfer allergens from food to which people know they are allergic to foods that they think are safe. This risk is not hypothetical. A study by the New England Journal of Medicine showed that when a gene from a Brazil nuts was engineered into soybeans, people allergic to nuts had serious reactions to the engineered product. Why? Because nut is an allergic product and the soybean is not non-allergic product. So when you will take something from the nuts and you will insert in the soybean, definitely those allergic reaction will get into the food also, and the people who will eat that one, they will get the allergic reaction. At least one food, a Pioneer hybrid international soybean, was abandoned because of this problem. Without labeling, people with known food allergies have no way of avoiding the potentially serious health consequences of getting genetically foods containing hidden allergenic material. So there is a issue also. If the people they will not clearly label that the food is genetically modified, so it will be very difficult for the consumer to identify whether there is any hidden risk with the food or not. So what these food producer they can do, or the companies they can do, they can label it food product and they can say that yes, this product has been extracted from that product and it may contain the allergic reaction, so consumers they can be aware about it. After that, antibiotic resistance. Another hidden risk of genetically engineered foods, genetically modified organisms food, is that they could make disease causing bacteria resistant to current antibiotics, resulting in a significant increases in the spread of infections and disease in the human population. Virtually all genetically engineered foods contain antibiotics resistance markers, okay, which help the producers identify whether the new genetic material has actually been transferred into the host food. For example, genetically engineered maize plant from Novartis includes an ampicillin resistant gene. Ampicillin is a valuable antibiotic used to treat a variety of infections in people and animals. A number of European countries, including Britain, refused to permit the Novartis BT corn to be grown due to health concerns that the ampicillin resistance gene could move from the corn into bacteria in the food chain, making ampicillin for less effective in fighting a wide range of bacterial infection. So what will happen, the food product and the animal product, they will grow the antibiotic resistance, and the bacteria inside the animal body, they will not die. So what will happen, antibiotics are given to the animals, that antibiotics will go to the animal and or the food product, and antibiotics aim to kill bacteria. Okay, that's why we are giving the antibiotics. But those antibiotics, certain bacteria acquire resistance, they will resistance and they will not die, and they will start to multiply. But we are thinking that we have given the antibiotics to the certain crops or certain animals, so there are no bacteria, but there are the bacteria, and this can increase the risk of food poisoning cases. So that is also the one of the hidden risk with the GMO food. After that, immunosuppression. The well-respected British medical journal, the Lancet, published an important study conducted by the Dr. D.R.S. Apred, Pujeshal and the Stanley W.B. Evan under a grant from the Scottish government. The study examined the effect on rats of the consumption of potatoes genetically engineered to contain the biopesticide Bacillus. The scientists found that the rats consuming genetically altered potatoes showed significantly detrimental effects on organ development, body metabolism, and immune function. So genetically modified food, they can also affect our immune system also. So that is also one of the risk. After that, genetically modified food, they may induce cancer also, especially breast cancer, prostate cancer, and colon cancer. So, along with its approval of genetically engineered foods, the FDA in 1993 also approved the use of genetically engineered recombinant bovine growth hormone used to induce dairy cows to produce more milk. So, what happened in 1993, when the dairy cows they reduce the milk production? So, the scientists they developed the new formula, and that was induced to dairy cows to get the more milk from the cows. At the time, the FDA assured consumers that the milk was safe. Since then, however, the regulatory bodies in both Canada and Europe have rejected the drug, citing numerous animal and human health concerns. Perhaps of most immediate concern for consumers is that research shows that the level of hormone called insulin, like growth factor 1, are increased in dairy products produced from cows treated with the RBGH. Okay, that is the one. The Canadians and the European further found that the FDA had completely failed to consider a study which showed that the increased IGF-1 in the RBH milk could survive digestion and make its way into the intestine and bloodstream of consumers. These findings are significant because numerous studies now demonstrate that IGF-1 is an important factor in growth of breast cancer, prostate cancer, and colon cancer. So there are the chances with the genetically modified food, it can induce the cancer as well. So genetically modified food, they can also lost the nutrition value from the food as well. So genetic engineering can also alter the nutritional value of food. In 1992, the FDA's Division of Food, Chemistry and Technology found contaminants chemistry examined the problem of nutrients loss in genetically engineered foods. The scientists involved specifically warned the agency that the genetic engineering of foods could result in undesirable alteration in the level of nutrients of such foods. So the level of nutrients which is modified by the genetically, so those can also lose the nutrition value as well. Once again, the FDA ignored findings by their own scientists and never subjected the foods to mandatory government testing of any sort. So these are the issues with the genetically modified organism foods. So there are some benefits also, and there are some issues also. Now it's purely your decision which food you want to take, but it's very difficult for us to identify whether we are eating the genetically modified food or not, because because the country and the company they are producing the genetically modified food, they are not declaring on the label. So the label should be declared there, so at least the consumer, they are consuming that food, they should know that what kind of food they are eating. If they, and it's their choice whether they want to eat it or whether they don't want to eat it. So at least this much of freedom they should get it. So thank you so much for your time and patience. I hope you like this video. Please do not forget to like my videos, subscribe, share, and comment if you need some suggestions or any other information. Thanks for your time, and once again, thank you for your support and love. Please do subscribe. Thank you so much.